Okay, sir. With both of your permission, may I start this session, sir?
Yes, please. You can, please.
Thank you, sir. Assalamu alaikum and good evening. I am Mohammad Rafiul Islam, lecturer, Department of Textile Engineering, Port City International University, welcoming you all to one of the keynote session of International Conference on Sustainable Development in Technology for Fourth Industrial Revolution, ICSDTIR 2021. As the speaker of this keynote session, we have among us Professor Dr. Abu Sadat Mohammad Saim, Research Associate, Research Ethics Officer and Safety Coordinator, Manchester Fashion Institute, Manchester Metropolitan University, UK. To chair this session, we have with us Dr. Muhammad Tajul Islam, Associate Professor, Department of Textile Engineering, Ahsanullah University of Science and Technology, Bangladesh. He did his PhD from New Zealand and editor, Coloration Technology, Wiley. And he is also a fellow of Textile Institute and the Society of Dyes and Colorists. If I may, I would want to give a gentle reminder of some basic rules to ensure an uninterrupted session. During the speech, all other participants will have to mute their microphone. If the participants have any question regarding the ongoing speech, all are requested to submit their question in the Q&A box section. And live Q&A section will be conducted by session chair at the end of the session. Now, I would like to request Dr. Muhammad Tajul Islam sir to lead this session. Sir.
Thank you, moderator. Thank you so much for your kind introduction. And please let me correct you. I am not exactly the editor of the Coloration Technology Journal. I am one of the member of the editorial panel. Again, thank you. So dear audience, good afternoon and assalamu alaikum. I'm really glad to welcome you all to a very timely keynote session titled Digital Design Technology and Sustainable Fashion. I really think it is a timely talk. Please let me explain. We know the fourth industrial revolution is building, it's happening, it's evolving in a very tremendous speed, I would say, in an exponential rate, based on the super fast digital progress. So, and in order to respond to this fourth industrial revolution, our textile industry, fashion and clothing industry must also need to be digitalized in every possible aspect, obviously in a sustainable manner. And you would be surprised to know that according to a study which was done probably like 10 years earlier, the amount of waste our textile, our apparel manufacturing industry generating per year is so huge that you can literally wrap the whole world 100 times with this amount of wastage fabric. Fortunately, researchers around the world are working hard to address this issue, to reduce this wastage. And we have one of these researchers among with us today's afternoon session. And actually, he is our keynote speaker, Dr. Abu Sadat Mohammad Saim. Dear audience, you are the current and future leader of our textile industry. And I truly believe this keynote talk will be very interesting and beneficial, obviously helpful for all of you, including me. I'm sure you all, including me, are eagerly waiting to learn more about this research directly from our keynote speaker. Before listening from him, please allow me to introduce him formally, properly. Dr. Saim is working as a research associate and research ethics officer, also safety coordinator of the Manchester Fashion Institute of Manchester Metropolitan University, UK, where he spent his time mainly in reviewing research ethics applications, training staffs and students on research ethics, along with his regular job, obviously teaching roles, supervision roles, supervision PhD and MSc students, then research roles. His research area mainly covers digital prototyping, sustainable materials, process innovations. So Dr. Saim started his career in textile industry in Bangladesh after immediately graduating from completing his undergraduate from the BUTEX, which was a college under the Dhaka University back then. And then he started his career in the academia after completing his MSc as a Dart scholar from Dresden University of Technology, Germany. He's also a Commonwealth scholar. He completed his PhD from University of Manchester under the Commonwealth Scholarship. And he's a fellow of the Textile Institute and council member. Um, Actually, I would like to stop here because his complete list of award and achievements is too long to mention all of them. So please welcome our today's keynote speaker of the session, Dr. Abu Sadat Muhammad Saim.
Thank you very much, Dr. Tadal Islam, chair of this session, for introducing me and also giving me this opportunity to present my work. And also I'd like to thank the organizer of this conference and the moderator of the event for inviting me to this prestigious event and prestigious session. I'm really feeling honored to be part of it, and I thank you. I express my gratitude and thanks to you all. First of all, I'd like to share my screen with you. And can chair please confirm me that if my screen is visible from your side?
Yes, I can see your screen.
Okay, thank you very much. So I'll go to the presentation mode now. Okay, as you have already heard and know, I'm going to talk about digital design technology and sustainable fashion. So I'll move on to the next slide directly. I thought I would say something about my background, but I'll not spend any time on it because the chair has already told about my background. So I'm basically a textile technologist in profession. I worked in different universities in different time, and also for a short period of time I worked at the university at the industry. To other things that I just would like to add that I am chairing a symposium, this being organized by our university, which is called Digital Fashion Innovation Symposium. It will take place in June. This is the second consecutive event. We organized the first event last year, and that was very successful. So we are going to organize the second event this year. So I'm acting as a chair for this online event. And I'm also an editor of an newly launched international journal known as iLetters, Journal of Innovation. So together with a few other colleagues from different universities, recognized universities with very highly reputed researchers and scientists, I'm working for this newly launched journal. Okay, just would like to give a very brief highlight quickly about my research, although our chair has introduced my research background already. One of my key research area is digital fashion innovation, which includes Industry 4, and which is very much related to this event, this conference. And in this area, I worked on zero waste pattern cutting, including digital design, and I focus also on virtual fashion prototyping and avatar or human model generation from body scan data. I have so far published my work with these journals. All of them are very reputed and top ranking in the discipline: Journal of Textile Institute, International Journal of Fashion Design, Technology and Education, and International Journal of Clothing Science and Technology. My second focus of research is, although related to digital fashion and Industry 4, that is wearable technology for fashion. Wearable technology is a new thrive or important area in research, which almost every university is trying to get involved in. And our university also has got a wearable technology research group. I'm part of that. Within this area of work, I'm focusing on smart clothing design and also textile-based ECG sensors development. I have so far published my research with these two reputed journals. One is the Sensor, leading in the sector of wearable technology, and also the Textile Progress, which is published by the Textile Institute. My third area of research, as I'm working as a full-time researcher, I can't confine myself to in one area. Depending on the project that is coming to the university or the university's area of interest, I need to move across discipline to discipline, and some of my works are really multidisciplinary. So another area I'm focusing on with my research is sustainability. On this topic particularly, I'm trying to look after or investigate the sustainability and environmental issue of fashion and textile, as well as I'm looking into the innovation of sustainable materials, for example, biodegradable composite materials, and etc. So I have so far published my work on this theme with the journal named Journal of Cleaner Production. That's also very reported and one of the top ranking journal of this field, and another is Journal of Composite Materials. So this is a snapshot about my research activities. Now I'll move to the outline of my presentation today. What I'm going to cover in the remaining time is about United Nations Sustainable Development Goals and fashion industry, how these two things are related. And then I will introduce my research on digital design technology and how it can support the United Nations Sustainable Development Goals. And then I will just give you a few brief idea, including few examples of my concurrent research on zero waste pattern cutting for mass production of apparel, which is a digital design technology, and also virtual fashion prototyping for zero physical prototyping, which can be also implemented in the fashion industry, again related to Industry 4 and the digital design concept. Okay, now let's move on to the United Nations Sustainable Development Goal. We know that this set of goals United Nations has declared a few years ago, which is called the United Nations Agenda 2030, which is also known as a blueprint to achieve a better and sustainable future for all by 2030. We are very closely approaching to that. We are in 2021 now, so within 9 years, what can we achieve further? Under this agenda, United Nations has set 17 goals, as you can see. I'll not read out everything. I will touch a few in my remaining slides. And within these 17 goals, there are 169 targets that needs to be fulfilled to be able to achieve a better and more sustainable future for us by the deadline set by the United Nations. Through my research, I have started to get involved with the sustainable development goals set by the United Nations, and we thought that our work should have some contribution in achieving this, because we are, as a part of the society and part of the world, we have got our responsibility also to play some role in this area. Right. Now let us give you a brief idea how fashion industry is related to United Nations Sustainable Development Goal. Just to mention here that when I say fashion industry, I include textile industry, because full fashion supply chain includes fiber, fabric, dyeing, processing, garment manufacturing, everything. So whatever I'm going to mention here is all connected to both fashion and textile. The industry is one of the top industry in the world in terms of value. Fashion industry is today $1.2 trillion industry. From the economic point of view, this is probably, if I'm not wrong, just next to the petroleum industry. But this industry is, although highly economically important, but also at the same time very important for the environment. Not only positive point of view, rather also for negative point of view. As you can see, the industry produces 20% of the global wastewater produced by all industrial activities in the world. And that is conflicting with the United Nations Sustainable Development Goal number 6. This industry emits about 10% of the global carbon emission. And this emission is even higher than the aviation and the shipping industries emission of the carbon emission or the greenhouse gases, which conflicts with the SDG 13. Cotton, you know, is one of the very popular fiber and very much preferred by the consumers. And this cotton industry is only the cotton production only take place only on the 3% agricultural land of the world, 3% arable land. But although small quantity of land in the world is producing cotton, but this cotton production or cotton farming is responsible for the use of 24% insecticides. So how much chemical uh, insecticides or chemical hungry the process is, you can think from this. The textile industry, because we have now started to learn about or hearing a lot about plastic pollution, microplastic coming to the water body, and that's going to the fish and on our food circle, and again coming back to our body, which is now a serious concern for the global scientists and the researchers. And textile industry is a major contributor to this problem, which conflicts with the SDG 14. We all know about these working conditions we had in Bangladesh. We had experience in many times, which is related to the SDG 8. Unsafe processing is a hazardous substance used in the production. Many chemicals, for example, azo-dyes have been used. Even if azo-dyes are now banned, but there are still some chemicals which can be harmful for the animals in the water body, or if it comes directly to human body, could make harm to human skin or human respiratory system. So which is conflicting with the SDG 3. Irresponsible consumption and production process. When we look at ourselves as a consumer of textile product, we are very much irresponsible, and this is true for more or less everybody. Probably if we minus Mahatma Gandhi, who used to use only one cloth every day or throughout his life, except him, probably everybody on the earth is quite a irresponsible users of clothing. If you just look back to your cupboard, you'll see that you have a lot of garments, shirts, pants you bought, but you probably don't use that much, that remain idle in your cupboard, in drawers, and then after some period of time, when you buy something new, you simply throw it out, and which go to the landfill. So this has become a common habit for us. This is because this textile materials has become very cheap, and we can produce a lot of textile material in the country like Bangladesh. So we don't care that how many textile we are buying and keeping in our storage. But all over the world, this is becoming a problem, because at the end, these all items are going to the landfill, which is an environmental concern. So as you can see that textile industry, fashion industry is directly related to the Sustainable Development Goals of the United Nations. And to be able to achieve a better future for us by 2030, we need to work, we need to do something and work jointly, collaboratively to address all these issues that is being created by the fashion industry. And we have taken a small attempt from our part to play a small role in supporting United Nations Sustainable Development Goal. Okay, through our research, we wanted to first identify what are the problem areas in the fashion supply chain or production system, which are the most contributor to the problem when it comes to sustainability. As you know, this is the flowchart or the flow process of apparel product development, which takes place at the early stage of garment production. And pattern cutting is a unavoidable path in the production process. You must go through this process. And as we have identified, this is one of the most problematic area in the total textile and fashion supply chain. At present, the pattern cutting system which is used in the industry is maximum 85% efficient. In other words, we say that we can achieve maximum marker efficiency of 85% through the current process we are following. No matter what software you use, how valuable or expensive the software is, and how expert your pattern cutter and technical designers are, you can't go higher than that. Maybe 66, 86, 87, but in an average, the industry around the world is 85% efficient when it comes to pattern cutting. When you consider this in terms of fabric that's being produced in the world and wasted throughout this process, we came to know from any statistics of 2012 that 60 billion square meter of fabric was simply scrapped during the fabric cutting process in apparel mass production. So this is a huge area, problem area, and we need to address this. We need to reduce the fabric wastage, and for in other words, we need to increase the efficiency of the marker so that we can utilize more fabric, and by utilizing more fabric, we will need to produce less fabric. That's mean ultimately, as such a proportional way, it will reduce the carbon emissions and other pollution related to fabric production in the supply chain. And another area within the fashion supply chain is the fit checking, for which we need samples. We call, in the garment terminology, industry terminology, we call it sample making. Another word you can say is prototyping. Throughout the garment product development process, we need to produce several physical samples, and these samples are made in countries like Bangladesh, China, Vietnam, and then shipped by DHL or FedEx or other courier service to the buyers and in Europe and America. And according to our research, it says that for every item or style of garments which is produced in the industry, at least 2 to 10 prototypes or physical samples are required, and they need to travel all over the world, and which contributes waste in most of manpower, material, as well as contribute towards the carbon emission. So this is another problem area that we need to substitute this physical prototyping process with a virtual or digital process so that we can avoid the need for producing physical samples. So these are the two problem areas we have identified, and we thought that through our research in the area of digital textile design and fashion design, we can support the achievement of United Nations Sustainable Development Goals. Now, I will move on to the work that we are doing, that we are trying to implement zero waste pattern cutting digitally to address the problem one, and we are trying to develop new processes and optimize existing processes in virtual fashion prototyping through simulation technology, 3D simulation technology, so that we can avoid physical garments prototypes. And through these, we have targeted to support or play a role in achieving the following goals. So that's our plan now, and let's see, or just let me brief you what we have been doing in the recent past. Now, let's focus on zero waste pattern cutting first. Zero waste pattern cutting is not a new concept, and in our society in Bangladesh, we have got good examples of this. For example, the sharis, our mothers and sisters or our daughters using the saris, is a rectangular piece of fabric. To make these garments, not a single piece or a small part of the fabric is wasted, just a rectangular piece. And also the lungi we use, or the dhuti we use, is also made from a rectangular piece of fabric, but in tubular form. Sometimes in case of lungi, there is a straight seam. In case of dhuti, there is no seam. So this production of these garments doesn't waste any fabric. But the traditional garments that we see or we wear, like t-shirt, shirt, pant, etc., and all the styles that are produced in our fashion industry, in the garments industry, they produce a lot of garments waste. They can't consume 100% of the fabric. We say in the marker length or the marker area or on the cutting table, whatever you say. Is to utilize the full length and width of the marker of the fabric in the cutting table, no matter which way you want to say it, is called the zero waste pattern cutting. This concept is not new, as I said, that this has been there for several years. But the problem is, until we started the war, we found that this concept is only used in the tailoring environment for making one or two garments in one specific sizes. And when we started working on this area, there has been no demonstration of how this technology or this technique can be applied for mass production. So it was previously only for the tailoring concept, making one, two garment for a specific. And another issue is the design problem. As I want to just go back to my previous slide. As you can see on the screen, the garments which are claimed to be zero waste, they are actually in concept not zero waste. Although you can see that they are utilizing the full fabric, but they are causing unwanted bulkiness in the fabric, in the garments. That's one thing. This unwanted bulkiness may not be comfortable or required for the modern day users. And the second thing is, this concept actually doesn't reduce the need for fabric. For example, if you need 100 meter of some fabric to make some garments, still if you apply this technique, as you can see on the screen, you will still need this 100 meter, because what you are trying to consume or use the full fabric in one garment or the full set of garments, so that you don't have the instant waste or the scrap fabric. But ultimately, this is not solving the problem. This is what it is doing, is just delaying the journey of the fabric to the landfill. And ultimately, it will go to the landfill. But the true zero waste pattern cutting should be not only aiming to consume the full marker length and width of the fabric, but also it should reduce the fabric consumption per item, so that you need less fabric for making the same amount of or the same number of garments. And if this can be achieved only, then you can produce less fabric than what we need at the moment. With less fabric, you can still produce the same number of garments, but you can avoid the waste. So this was the scenario until we started the work. So we wanted to apply this technique for mass production, which was not presented before or demonstrated before. Again, what we want to do, we want to reduce the consumption of fabric or use of fabric per item, so that you don't need that much amount of fabric that usually you need. And also the design bulkiness, that is a problem, but such a bulky design will not be always accepted by the consumers. So these are the problems before we started working on this. So what we did first, that we developed a strategic framework for implementing zero waste pattern cutting for multiple sizes. Because if you can apply this technique for multiple sizes, this means you can apply this for mass production, because in mass production, same style is produced in multiple sizes, and in the marker, in one marker, there is component for different sizes of garments. So that was the first thing that we wanted to achieve. So we developed a framework, and through framework, what our plan was that when we start pattern cutting or design of a garments, we first think that what are the possible technique available for zero waste pattern cutting. For example, zigzag concept is one of the concepts that you can apply, so that you can shape the outer perimeter or the outer border of the pattern pieces in such a way that it will match each other, keeping no wastage in between. But it doesn't always help to reduce the fabric consumption per item. So then we came up with some other things, what we called inverse negative space, that I will demonstrate you a little later instead of discussing this here. So we developed a framework, and then we used digital pattern cutting technique with traditional digital software available for pattern cutting. And also we did marker making. As you can see here, I'm not going details to that. And we also make a physical prototype of the garments to check that whether fit is acceptable, because that's very important. You don't only achieve the zero waste pattern cutting on, and then reduce the fabric consumption. The fit must be good, otherwise your consumer will not accept it. And what we found through the technique that we applied and the framework we developed, we could achieve over 98% fabric utilization. We took two simple design, as we have seen in the previous picture. One shirt with a hood, we commonly called it hoodie, and a pair of trousers. And we modified the outer boundary of the garment, which we call silhouette of the pattern. We modified the placement of the pattern pieces on the marker so that we could utilize maximum fabric in the marker area. Just to mention here that this work we did in the laboratory scale, and that's why we tried to use some available or unutilized fabric for making some design style on the garments, which may not be applicable in the true life, real life garments production. If we consider this, then the achievement of fabric utilization may go little bit down, like 95% or 94%, whatever it is. So even if it is 94%, 95%, this is much higher than what is being achieved in the industry at the moment. So from that point of view, that concept is very promising and interesting. And we introduced a new concept which wasn't introduced before or presented before, that what we call this inverse negative space. This inverse negative space is that when you make a pattern for one size of particular garment, say for example for this t-shirt, as you can see, when this is the front part of the t-shirt or back part of the t-shirt, what you can see, when we make the t-shirt, the under the armhole in both side area, as you can see, armhole, there are some unutilized fabric. So this is what we call negative space in the pattern, in the marker. The negative space means unutilized space. So we thought that these negative spaces can be utilized to make other component of the garment. For example, we shaped the armhole in such a way that the negative space, as you can see here, can be used to make the hood of the garment. So and by inverse negative space, we mean that from the large size pattern of the body, the negative space will give a component for a small size of the garment. So this is what we call inverse negative space. That's a new concept that we introduced that wasn't known before, and we found that that is very effective when it comes to implementing zero waste pattern cutting in the mass production. Right. We introduced a new concept or new model of apparel product development, fashion product development. So at the top you can see the conventional process. I'll not go details, you know all about this, but we introduced the process that you start with market research, that is the first step of product development. Then in the middle you apply zero waste design, zero waste pattern cutting, and zero waste marker. And for details of what zero waste design is and what zero waste pattern cutting and zero waste marker, so you need to go back to our framework that we developed. And then you do the prototyping and mass production. This is a new apparel design model or the process, you can say. So this is we call zero waste apparel design, and that can be applied for the mass production, which is the key thing of the work. We published this work with my students, as you can see. This work was published in the Journal of Textile Institute last year. So it's a very latest work. And that's the findings directly supports the sustainable development goal of the United Nations when it comes to fashion industry. Now, so this is the first part about zero-waste pattern cutting. Now I'll move to the second thing, this virtual prototyping technology. There's another research that we have been conducting that's related to the sustainability of the fashion. So when it comes to virtual fashion prototyping, just let me just clarify one thing at the beginning, that there are two common approaches. There might be more, but the common approach, two common approaches are being practiced in the industry. One is you design 3D, and from 3D you extract 2D pattern, and this is very promising. Through these you can achieve right fastness, right fast pattern. From the very beginning, the first set of pattern should be correct, but unfortunately the technology is not that much mature enough for industrial use. You won't find software technology available which utilizes these approaches at the moment. Other thing is that you start with 2D pattern. This is a traditional concept. You do 2D pattern in the industry at the moment, but then you convert this 3D pattern into 3D garments, which we call the virtual prototypes, and that can be a substitute for physical prototype as well. So there are two concepts, and we, through our research, trying to investigate in the both of the area, and for this theme, our work is focusing on developing new process. For example, for 3D to 2D pattern unwrapping, the technology is not matured enough to be used in the industry, so we are trying to improve the technology, so we are developing process. And for the traditional process, which is already in the industry now, 2D to 3D clothing simulation, we are trying to optimize the process so that the industry can get the maximum benefit out of the technology. So that's our approach in this area. So okay, I have summarized this. Now let's understand first what we expect from virtual fashion technology. So virtual fashion, when we talk about virtual fashion, it comes with three components. One is digital design, and there is material simulation and virtual avatar. Virtual avatar is the common thing that you see in the cartoon animation and animation movies. But for the fashion industry, we need anthropometrically correct, anatomically realistic avatar. Otherwise, the virtual prototype that you produce will not be perfect. So you need to be able to produce a virtual clone of a real human inside the computer, 3D computer, 3D environment of the computer. That's why what we need first is realistically correct and anthropometrically correct avatar. Then what we need to make sure is realistic simulation of material property within the graphics design environment. This is not only photorealistic, because there are a lot of simulation work going on. They focus on photorealistic work. For example, in the cartoon movies, they also have clothing on it, the cartoon character, but they don't consider the real properties of the fabric or the material, like they don't differentiate between silk and cotton and denim. They don't consider the neat weaving structure, etc. They produce a photorealistic simulation of clothing or textile. But for virtual fashion technology, or for the fashion industry, the simulation has to be material specific, not photorealistic. And also the design that we develop, digital design, this has to be right first time, so that you can achieve true time saving, money saving, material saving output. Our work in the area of 3D to 2D pattern unwrapping is focusing on new process development, as I can say. So in this area, we developed a process for producing a 3D garment template on which you can design garments and then extract 2D pattern directly. And for this work, we started with body scan data, and then we processed the body scan using some available software known as Geomagic Studio, Geomagic Wrap, etc. So we convert the body scan data into several different formats, and finally we produce CAD model which was used for the further processing. And then from the CAD model, the golden figure that you can see, we extracted slice of curves specific to the parameters related to garment production, and we parameterize those with size values so that you can change the size automatically. And then we reproduce a surface using the 3D CAD simulation technique so that you can have a 3D template or 3D design platform on which you can design garments. As you can see, you can draw, and then once you draw the garments, if you like it, then you can convert this 3D design into 2D. It's something like you peeling off banana skin. So once you peel off the banana skin, you get the 2D version of a 3D structure. The same concept you're applying, because human body is 3D, so that doesn't make sense to start designing garments for a 2D format. So if you can design the garments in 3D format, and you can, if you have a true geometrical representation and anthropometric representation of the human body in the system, then you can develop the pattern correctly first time. Who are familiar with the pattern cutting system, you know that the 2D patterns that we start working is never correct first time. You do a design, make a garment, try, and then come back to the 2D design, correct it, etc., etc. So this is an error and trial process, etc. So to avoid this, our work focused on this 3D to 2D pattern unwrapping. But this work is still in the research phase. The software industry hasn't implemented it into software. So this is an area which can be, explored or focused on. I am trying to approach the software industries in Bangladesh and in the UK, and trying to share this concept with them. Then this is the area that we can be working together. And in Bangladesh now, IT industry is expanding, and government is focusing on, or the government is supporting on homebound software development. But in Bangladesh, we are talking about software export. But in Bangladesh, we are using a lot of foreign-made software system in almost in every industry, and we are spending or draining out a lot of money by buying software from abroad. But specifically in the fashion industry, textile industry, as I know, there is no software made from home or made in Bangladesh. There are few, database software which can used for costing or for keeping record of merchandising or doing the payroll. There are some software system available which are based on database program. But when it comes to design, computer aided design, computer aided engineering, there is no software developed from Bangladesh. And but the industry should focus on it. We have got a lot of universities now. We have got a lot of computer science graduates now. So why don't we try developing the software by ourselves? So when it comes to, because when you want to make a new software, you have to include some novel property, and this is what it is. Then the novel property that you need to include, that producing product, I mean the features from 3D to 2D, so that you can get pattern right first time. So we know the know-how. Now we need to just convert it into an usable software system so that industry can use it. So this is what our system, because what we did to do this work, we utilized several 3D design systems which are not used for the textile industry. Some are designed for the mechanical design, some are used for the car industry, automobile industry. So we tried to combine several software systems and do small part in different systems to reach this. So now what we need is a single software which will have all these features. So in my system, what we developed, this 3D platform, you can design garments on it, and then you can convert into a 2D platform, 2D pattern pieces, as well as you can do 3D simulation, 3D prototyping. As you can see, there's different design illustration you can do, where these garments could be used as a virtual prototype as well. So in addition to this process development, we also tried to develop the optimized parameters for developing pattern from 3D designs, or 2D to 3D to 2D extraction. So one of our work involved to that as well. So I don't want to go in details to that at this stage, but we published the work with the International Journal of Clothing Science and Technology, which is now available online. Now, this was one part of our virtual prototyping work, virtual prototyping research. Now I'll go to the other work, that is the traditional 2D to 3D simulation. This technique is now already available. There are software tools that supports uh, converting 2D pattern into 3D clothing, 3D garments, the virtual prototype. So there are several software available, but we try to optimize the process, existing process. Even though the software tools are available, we have found that industry is not taking all the advantage of the options that are available within this system. So our work on this area is focusing on optimizing the process so that the available technique can be used even in a better way in the industry. So for our research also, this is the flowchart of the research. I will explain every step in the next slides. So we started with body scanning, because body scanning can capture the human geometry or human architecture within a blink of an eye. Just in a couple of seconds, you can capture the whole body, and you can extract as many as measurement from the body if you want. And or if you want to make a 3D avatar from human body, then body scanning is the only starting point so far. So we have got a body scanning system from USA, and we utilize this technology to scan real human body to capture and then produce avatar in 3D simulation. Sometimes we extract measurement and use the available avatar available in the commercial software to resize and readjust avatar, as you can see this here. Then we tested fabric to capture the real fabric parameter to incorporate in the simulation system of the software. And then we did digital design, pattern cutting, and then the traditional way is to place 2D pattern on a virtual avatar and then incorporate the material properties of the fabric properties and then do the 3D simulation. So that's what we did. But this is already known. You can do it with the existing software. But what we tried to improve is the virtual fit checking technique. So far, the industrial software, what it offers and also how it is used, that you make a virtual garment within the computer environment, you rotate it 360-degree top to bottom, right to left, and you check the fit visually. This visual assessment, what we call subjective, and this can be wrong because this virtual avatar cannot talk. When you try a garments on a real model or real human body, the person who is wearing, the person can tell you that this is tight in the shoulder area or this is too loose in the waist area. Then you go back and adjust a pattern and remake the garments. But the virtual prototypes, the avatar in the computer system, it cannot tell you that where it is tight, whether it is loose, etc. Now there are some options called tension mapping, stretch mapping, etc. As you can see on the screen, these mapping tools tell you that where it is tight, where it is loose, etc. But the problem is, again, this is an subjective analysis. You analyze it visually, and the problem is what we found, that the software still cannot recognize the material properties correctly. So that, for example, in this design, as you can see, that if the radial area is more or wider, this can be tighter in this fabric, in these garments, the area with the body. But if you change the fabric property, then we found that although the mechanical value of the tension is higher, sometimes the visual representation shows the narrow band, narrower or smaller area in dark or red shade, indicating that probably if you change the fabric, the tightness will improve. I mean, it will be more relaxed. But in true sense, it is not. When we look at the technical value of the tension, like in unit of ground force per centimeter or the stage in percentage, sometimes we see that this visual analysis gives fully wrong impression. So what we did, we tried to develop an objective approach of fit analysis. So by objective approach, we mean that you take the decision based on data, numerical data, not only based on the visual analysis. So we try to find a correlation between the ease in pattern with the tension in gram per force and centimeter in the virtual prototype, and we try to develop a correlation, and this correlation can help us to develop an idea to assess fit objectively. So this is an approach what we call objective fit analysis technique, which is also we call an optimization of the process which already exists, but through our findings the industry can be benefited by using the technology more effectively. So we also published this work back in 2016, as you can see, which is also available in public domain. So these, until now, I have summarized what we have done so far in the area of virtual fashion and the digital design and how it's correlate to the correlate with the sustainable development goal. Now I'll move into something more to discuss about how we are trying to convert our research finding or move or transfer our research finding from lab to the production plan. So if you only do the, sorry.
I hate to interrupt. Actually, we are running out of time.
Okay.
We have crossed already 6 minutes.
Okay, can I get 2 minutes to run out?
Sure, please.
In 2 minutes, I'll finish. Okay. So
yeah, sure.
My main thing is done. Now just a few things. So we are now working to implement our research into the industry. Now we have started with a project called GCRF, which is called Global Challenge Research Fund, which is a fund from the British government to support sustainable development in the countries like Bangladesh. So we have launched this project in collaboration with the colleague from engineering department of our university. The project is already running. So, and the fund is coming from the British government, and this is related to sustainable development goals. These are the objects. So through this, actually, we are trying to develop research capacities in zero waste pattern cutting and material sustainability in Bangladesh. So our partners are now Butex Textile University and BGM University, and associate partners are Buet and BGRI, and we have got media partner Textile Focus. So under this project, we are running 2 skill trainings. Will be including 3-4 participants from Butex and BGM University, plus few more participants from universities which offers textile studies in the training. The trainings will be fully online. If the Sports City Industrial University is interested, they can join part, but this training will be coordinated by Bangladesh University of Textile, and our local counterpart is Dr. Abbasuddin Shayok. So if you're interested, you can talk to him and can participate. And then at the end, I'm very end of my my presentation. I'm just finishing, giving you some invitations. So I'm very open to collaboration. If your university is interested, we can collaborate in research. I'd like to also invite you to a few events that I'm involved with. And then there is Textile and Fashion Innovation Congress. It's a Manchester-based organizer. They're organizing it. I'm supporting them. This is taking place in April. Call for paper is open. If you want, you can participate to this. As I said, that I'm chair of the Digital Fashion Innovation Symposium. This is organized by our university. Also, again, the call for paper is open. You can participate and submit your research work to it. I am now also acting as an editor for this special issue on digital fashion innovation from the International Journal of Fashion Design, Technology and Education. So, and the call for paper is again open. You can still submit your research article to this special issue if you want. So that's all from my side. So thank you for your patience hearing. And now I'd like to, invite you to ask questions if you have any questions for me. So that's all from my side. Thank you very much.
Thank you so much. I really enjoyed it. It was really, really engaging and so much beneficial information. Thank you so much. I would like to request our moderator, Rafiul Islam, to read out the question so that our speaker can answer them.
Well, thank you very much, sir. And also thank you very much for your nice presentation. So now the floor is open for the question and answer section. The very first question, to Professor Dr. Abu Sadat Mohammad Saim. 2D and 3D design, which are useful for textile sector and which process are easy? Sir.
Okay, now, if we look at the available technology, at present, the industry or the available technology supports 2D design first. You need to start with 2D design, and then you can convert into 3D. So traditionally, we do 2D, but to be able to achieve more sustainability, we need to move towards 3D for sure. I have been advocating for 3D technology last few years in different seminars and conference, but it seems that people didn't pay attention to this. But now, when this COVID situation has come during the pandemic, all the retailers, fashion retailers in the Europe and America, which are the buyers for Bangladesh apparel industry, they have now moving towards this 3D simulation technique. And now, if you talk to the industry, you'll see that they are now getting inquiries from their buyer that whether they can do 3D simulation. So this is what it is.
Okay, thank you very much, sir. The second one is there any cooperative study with your work and seamless garments production?
Okay, at the moment, no, we are not doing seamless garment production. So this is a separate area. I know there's people in different area working on this, but we haven't started this at the moment.
Well, we are moving to the next question. It comes from Shamim, Mr. Shamim. He asked for, we don't have adequate opportunity to do research on modern textile industry. By using MATLAB simulation software, Tripoli and mechanical engineer make easy their work. Please give us some advice, which skills should require if we want to research on modern textile industry.
Okay, and now to start research with, doing work with research, you first need to have the research skill. I conducted few webinars, online workshop with Textile University in the recent past about research skills. So what you need to know about how to conduct research, how to identify research gap, what has not been done yet and what you can do, and how to do literature research, and how to devise a methodology, and how to plan your own lab work or activities. If you know this process, then the rest of the process is very easy. We always think when we are in Bangladesh, when I was a student in Bangladesh as well, we also thought that in Bangladesh, we don't have sufficient lab equipment, we don't have sufficient budget for the research, etc. So that's why we can't do good research in Bangladesh. If you come abroad, if you come into a university like Manchester University or Manchester Metropolitan, where I'm working, or any university in the world, in America and Australia, New Zealand, wherever it is, you will find that they have the same problem. No laboratory in the world, in any university is 100% sufficient and full-fledged with all the equipments. So, but through your research planning, you need to decide that what you need, what you don't need, and if you need something, where you can get it. For example, if any facilities is not available in your university, that could be available in other university in Bangladesh or other university in the world. I can give you an example. I do collaborative research with Bangladesh Jute Research Institute. And in Bangladesh Jute Research Institute, we have already published a couple of peer-reviewed journal articles through our joint work. In Jute Research Institute, they have good facilities to produce jute fabric and product with jute, and they have got now heat press machine to do heat to produce thermo heated or thermal molded composite materials. But they don't have all the testing kit that you need to characterize this composite materials. For example, usually these electron microscopes are very expensive and not that available in Bangladesh. What they did, they produced the composite, they did the tensile testing, but they couldn't do the impact testing in their lab. They couldn't do the this electronic analysis. So they sent me the sample to me by courier or by post, and I did this test at our end, and this is how we could produce peer-reviewed article and complete the research. So this is what you need to think, that you'll have limitations, but if you know what you need and where you can get support, then doing research would be very easy. Thank you.
Okay, thank you very much, sir, for your nice answer. Someone is very much interested to know about which softwares do you use for 3D design, sir?
Okay, there are several softwares we use and several software we have been using. When it comes to avatar production, then we use Biomedical software to convert body scan data into an avatar. And when it comes to 3D to 2D pattern unwrapping, then we use Design Concept 3D, which is a software from Lectra. Design Concept. This is not promoted for the fashion industry. This is for technical, textile, and automobile industry. When it comes to 2D to 3D simulation, then there are several software systems are available. We used Optitex a lot. We also are trying to use Garber. At the moment, we are trying Glow 3D. So several software systems are available at the moment.
Sir, we had a question from Mohammad Ali, and he wrote down, tell me about the physical measurement and body scanning measurement and their accuracy, if there are any option like laser and white light according to the accuracy.
Okay, when it comes to accuracy, no process is 100% accurate. When it comes to manual measurement, what the problem is that interpersonal inaccuracy will happen. If I measure something, one person's chest area or waist area, I will get one measurement. If somebody else measures, they may get different measurement because they may differ in at what position I measure. They will measure in different positions. So for the manual measurements, there is a problem or the inaccuracy issues as well. And with digital system body scanning, there is an inaccuracy process as well, because no machine and no software can work accurately if you don't give them the right instructions. So the programming is the key thing. So you have to tell the body scanner that where it should measure the waist, where it should measure the shoulder, where it should measure the chest area. So if you can give the correct instruction to the system, then it will give you correct measurement. And also then with all measurement technology, and one key concept is called calibration. So the system should be calibrated accurately. If the calibration is not correct, you won't get correct measurement. This is true for all testing equipment. So if you do tensile testing or if you simply take the weight measurement, so you have to calibrate the machine properly. So this is true for body scanning as well. So this is the common mistake done by the people, that body scanning take few seconds to measure a human body. So people just come, switch on the scanner and get into the box and measure it, but the measurement they get is wrong because the system is not calibrated correctly. So there are inaccuracy issues in everything. And from machine, from software, you can't achieve 100%. You can't expect, because they don't have brain like human being. So for machine, you have to give the right instruction. You have to calibrate the machine correctly to get the correct output. So this is true for every machine you use it.
Okay, thank you very much, sir. And this one is the last
should we
question.
take any more questions? Oh, it's the last
this is
question.
The last
okay.
question,
Okay,
sir.
please go for it.
Okay. Professor said domestic students should try to go for textile softwares than buying from abroad. But the buyers mostly prefer those technologies from abroad which were in their requirements. Other than this, they wouldn't put orders. Then what should we do?
Okay, this is something, a cycle. I don't know how to break it, because the software companies are in the USA or Europe. The machines company, like all the famous textile machine companies, they are either from Germany or from Italy or from Spain. So what they do, they go to the buyers or the retailers in Europe and America. They do their marketing. They said that ask your Bangladeshi factories to buy our machines. So this is the way they are doing the marketing, And if you develop a product in Bangladesh, say it is a software or machine, and if you can prove this your product, your software or your machine works better than the European one, the Italian one or the German one, then you have to do the same marketing, because who is your buyer, you should know. Then you have to go to H&M office is in Bangladesh. You have to go to Marks and Spencer, again you have office in Bangladesh, and tell them, they see that my software is better than Lectra, my software is better than Gerber. You demonstrate them. So if you can demonstrate them, they will buy, they will recommend your software. But without proving that your product is the best, you can't expect that people will simply say that buy his product. Nobody will do it. This is the competitive world. So you have to develop the product, and secondly, you have to know how the international business takes place. So you have to design your marketing strategy. So this is what everything is. So, but I would say that Bangladeshi people are very good at marketing, and that's why they could attract millions of dollars of garments order from abroad to Bangladesh. So this skill is there. Now, our researchers, academics, scientists, they should play their role. They should attempt to develop homebound know-how, homebound technology, so that you can save money, you can save foreign country. And to do this, you have to prove yourself. You have to prove that your product works better than others. Otherwise, nobody will be, even you will not buy. If your colleague develop something and ask you to buy, you will not buy that one if you find an alternative product on the market. So this is how the business runs.
Okay, thank you very much. While we have a lot of questions from interested attendees, it seems everyone is excited to receive Dr. Abu Sadat Mohammad Saim among us, but due to the time limitation, we have to end for now. We expect to collaborate with Dr. Saim in future. Hope the rest questions shall be answered then. Now, I would like to request our session chair, Dr. Mohammad Najul Islam sir, to hand over the virtual certificate to our keynote speaker.
Can you please hold it for a moment? I would like to conclude something.
Of course. Sorry, sir, it's my mistake.
No, that's all right. Thank you so much, Abu Sadat Saim, Dr. Abu Sadat Saim. That was really fantastic presentation. Everybody was really engaged. I can see from their questions, from their interactions in the chat box and Q&A box. I myself really learned something. I had that wrong impression that jigsaw actually is a very good concept to minimize or to achieve a zero wastage in the cutting room. But it actually carried this wastage fabric to the apparel. So instead of cutting out instantly, it is actually carried out to the apparel. That was really fantastic of you to simplify it, to put it in a simple words. I learned it actually from this. And I just, out of curiosity, how would that be difficult? How difficult that would be to get a zero wastage from a stripe or check fabric? Because from my undergrad study, I know that it is very difficult to achieve higher marker efficiency for this type of fabrics, stripe or check fabric.
You're right. You're very much right. Although we haven't tried yet in our work, we tried with two simple design knitted product. We didn't try oven check and stripes. We have planned, because through the Global Challenge Research Fund project we're implementing in Bangladesh, one of the research component is to identify common styles from the Bangladesh factories, and then apply the framework that we developed and see how much we can achieve. To achieve this zero waste pattern cutting, is not only you can think of the role of the pattern cutter or the technical department. The designers, fashion designers, they also need to work collaboratively with the pattern cutting room to be able to achieve this goal. And for this, the designer has to be a bit flexible with this check matching, stripe matching, so that the more fabric can be utilized. But because in the traditional practice, we want to have very accurate check matching with the pocket and the body and the sleeve joint in the same area. And that if we are such strict, then it is really difficult to achieve this. So the designers who actually designs the garments, they need to be flexible, or they need to consider this mismatch as a design feature. so that this zero waste concept can be promoted. So it's a sort of joint work, combined work. So alone this couldn't be solved. You're right.
Yeah. I must agree. Yes. If designer also come forward to solve these environmental issues, then for the technologists like us, it would be really easier to cope with these environmental issues. And for your second part of the presentation, just a quick inquiry, like what is the current accuracy of this simulation from 2D to 3D? Although you have said there are so many factors, machines won't get you the 100% current accuracy, but I'm just curious, what is the current accuracy rate?
I don't have the answer in terms of a percentage or a numerical value, but as a researcher, what I know that the available technology, the software, say it is from Lectra or Gerber
Right.
or Clo 3D, whatever it is, they are very good in photorealistic simulation, but they are not that much good in material simulation. So which is an area still needs much development.
Thank you so much. And I can see there are some attendees from CST department and electrical department. You are so lucky that you have already know there is a very good area where you can work. Researchers around the world will be looking for a software which can actually work for the textile materials simulation properly. So I would like to request you consider it really thoroughly. And you have the contact person. You can contact our keynote speaker at any time.
I just want to
think.
add one word, is that
Right.
from Bangladesh, our researchers are trying to make robot for Mars, robot from NASA, which will
Right.
not have any impact on Bangladesh in next 100 years. So I would
Right.
invite our academics and researchers to focus on our problem. So textile industry is our industry. So we are spending a lot of money to buy technology from abroad. So our computer experts or electrical experts, they should focus on our industry, how they can contribute, instead of looking for the making Mars rover for NASA, which doesn't contribute to Bangladesh economy.
Right. Excellent. Nice thought sharing, and everything was really excellent and amazing. And I really personally look forward to collaborate in future. You have invited for some collaboration, and you are chairing. I didn't know you are chairing 2 sessions, and you are also editing as a guest editor for a journal, and you are also editor for a newly launched journal. I will be writing you soon. That's for sure.
You're very welcome. Welcome. I look forward.
Thank you so much.
You're welcome.
Thank you so much. With that, I would like to conclude our formal session for this keynote talk. And moderator, Mr. Rafiul, you may proceed with your rest of the procedures or formalities.
Okay, thank you very much, sir. Moving forward, now I would like to request our session chair, Dr. Muhammad Tajul Islam, sir, to hand over the virtual certificate to our keynote speaker, Professor Dr. Abu Sadat Muhammad Saim, sir, as a token of appreciation.
Well, this is really new thing. COVID-19 has brought so many things. I never thought of handing over certificates online. Yeah, I'm very glad to hand over the certificate on behalf of the ICSDTIR-2021 to our fantastic keynote speaker, Dr. Abu Sadat Muhammad Saim. And I also would like to again thank you for your time, and that was such a nice talk. It was really fantastic. And then Mr. Rafiul.
Yes, sir. Thank you very much.
It would be great if I could have handed it over in person, you know?
Yeah, in future, maybe.
We are hoping so, sir, in future. Okay, now I would like to request our acting chairman, Department of Textile Engineering, Mr. Jubair bin Said Oli, to hand over the virtual certificate to our session chair, Dr. Muhammad Tajul Islam, sir.
Thank you, Mr. Rafiul, for giving me a chance. I'm really honored I'm very much lucky to provide this certificate to my teacher, my own teacher, Mr. Tajul Islam, sir. and I am also thanking Dr. Abu Sadat Mohammed Saim sir for sharing such important knowledge among us, and I hope this from this session we are able to learn so many things, so many important things, so many technical things of applied manufacturing engineering and using of the software in the modern textile industry. Thank you so much, sir, and thank you again. Thank you, Dr. Mohammed Tajul sir, for organizing and for controlling this keynote session. Thank you very much, sir. Thank you.
You are most welcome, and the feeling is mutual. To get a certificate from my students is also a very honoring moment for me. Thank you again. Thank you, everybody. Thank you, the panelists. Thank you, the attendees. And again, thank you, Dr. Saim, so much for your nice and timely topic. I would say it's a very timely topic for this moment for our industry.
Okay, sir, just a minute. Now, I would like to request all of you to open your camera if you are comfortable enough so that we can capture this moment. Thank you, sir. Now we have reached to the end of the session. Thank you very much, Dr. Mohammad Tajul Islam sir, for conducting this keynote session. I also thank our keynote speaker, Professor Dr. Abu Sadat Mohammed Saim sir, for managing some time for us and for your nice presentation. I hope it will be highly motivating and beneficial for all of us. Thank you very much, sir. Have a good day.
Thank you.
You're
very welcome.
Assalamu alaikum.
Assalamu
Assalamu alaikum.
Assalamu alaikum, sir.